Hi, I'm Professor D.K. Panda from Ohio State University. Together with my colleague Dr. Jiawi Lu, we have an exciting tutorial coming up for Supercomputing 2017. It is titled Big Data Meets HPC, Exploiting HPC Technologies for Accelerating Big Data Processing and Management. In this short video, we'd like to provide you a preview of this tutorial and what it contains. As many of you must be knowing, we are in an exciting phase in the community where a lot of data is being generated, but with all this data, there is a lot of focus these days how to process and manage this data. And this is the field of big data in which we are currently going through. If you take a look at just an example of how this data is being generated, here is a very nice overview. Here you can see, like for example, the Facebook these days, like almost 4 million posts are getting posted every minute of the day. Similarly, if you see a YouTube, almost 300 hours of new videos are being uploaded in every minute. Similarly, like if you see here, like a Snapchat, almost like a 285,000 users are providing the snaps, and the list keeps on going on. So now the question arises, how do we actually process this data? So this is here, it is trying to show a quick overview of a multi-tier data center. So in a multi-tier data center, if you see, a lot of things are happening in the front end tier, components like Memcached or HBase, these are being used to carry out database operations. And also in the backend tier, we have like components like the Hadoop MapReduce, Spark, together with SDFS kind of operations are taking place. Now these kind of operations are scalable, and inside the data center they're also very communication intensive. But if you take a look at how they get implemented, you will see that most of the time in these data centers, these are based on sockets going over TCP/IP and typically going through the Ethernet on the traditional Ethernet environment. But the question is, can it deliver high performance? Of course, there are a lot of newer technologies which are being developed to provide high performance, like InfiniBand. So the question arises, how we can take advantage of these advanced technologies, networking technologies and their features to accelerate these big data operations. So here it is a chart which is trying to show like the trends in the networking technologies in the top 500 systems. So here you will be seeing all different networking technologies like InfiniBand and 10 gig. These are the kind of things which are emerging in the market over the years. And all these different networking technologies have all different features. Here it is trying to show a very broad overview of all interconnects and protocols in the Open Fabric stack. On the left hand side, you will see these are the traditional Ethernet based protocols, either going through the TCP/IP or even on the InfiniBand going over InfiniBand emulator, which is IP over IP. And also, of course, there are some Ethernet technologies which are based on TCP offload engine. So typically an application or middleware goes through the sockets interface and tries to take advantage of these technologies and the features. But on the right hand side, we have the native InfiniBand with the remote DMA or the RDMA capabilities, and then it also tries to take advantage of user space communication. So the question is, like, most of the software stacks are currently on the left hand side, and a lot of advancements have taken place, especially in the HPC field and the parallel file systems field, to move these designs to the high performance networks. So the question is, can we do that for even big data systems and applications? And while we are trying to take a look at the accelerating the big data, we also see there is an increasing trend these days in the community going from HPC to big data to the deep learning. And this is where a lot of kind of increasing usage is taking place in all these three different disciplines. And at the same time, a lot of things are also happening with respect to convergence of these areas. So then in this kind of a context, there is a lot of questions people are asking. What are the major bottlenecks in the current big data processing and deep learning middleware such as Hadoop and Spark? What kind of can these bottlenecks be alleviated with new designs by taking advantage of HPC technologies? Can RDMA enabled high performance interconnects benefit both big data processing and deep learning? Can HPC clusters with high performance storage systems like the SSDs, parallel file system, etc. also benefit these applications, and how much performance benefits can be achieved through these enhanced designs, and how to design benchmarks for evaluating the performance of big data and deep learning middleware on HPC clusters. So the broad idea is that how we can bring HPC big data processing and the deep learning into a convergent trajectory with the newer advancements in the technologies. So to answer all these questions and to provide a very comprehensive solutions to all these problems, we have put together a very interesting tutorial. This will be the outline of the tutorial. We'll start with an overview of the different kinds of MapReduce and RDD programming models. We'll go over the architecture of all these components, the Hadoop, Spark, Memcached, gRPC, and TensorFlow. We'll try to see the advancement taking place in the fields of modern interconnects and protocols. And then after that, we'll try to ask a lot of questions which outlines the challenges in accelerating all these components. And we'll also get an overview of the benchmarks and applications being used in these environments. And after that, we'll try to propose a set of case studies and in-depth performance evaluations to demonstrate the benefits of these accelerations. And after that, we'll try to introduce a project called High Performance Big Data, which my group has been working for several years. Some of you might be familiar with that. We'll try to go into that project and provide a lot of case studies and trying to give some information on the associated releases. And we'll also try to provide you an overview of other activities taking place in the community to accelerate big data applications, and also try to show a set of advanced acceleration case studies. It will be of interest to you. It will be held on Sunday, November 12th in the afternoon in room 201. So we look forward to many of you attending this tutorial to get an insight to all these different emerging challenges. For the time being, if you have any questions, please feel free to send an email to either to me or to my colleague, and we'll be happy to answer these questions before the tutorial day on the supercomputing. So we look forward to seeing many of you, and thanks.